Now, talking about the supervised learning, where we said we know the output, we have certain input, we have a quality. We are referring here as a signal to interference and noise ratio as an example for technical people. So let's take an example of 4G network here, and we are saying with changing signal to interference noise ratio, or in a layman language, signal quality, how my throughput is going to change. And throughput is the user speed or data speed. So how my data speed is going to change, and there is some correlation. There is some correlation that has been made. How it has been identified, we'll talk about the mathematics in the subsequent sections. How we arrived to this is the equation the machine has derived on the basis of the past data. We fed in the system, in the machines, the huge amount of data for many cells, many sites within the 4G network, and for many days and weeks and months. And on the basis of that, machine has identified that this is the equation. If you would like to predict the throughput, X is an input, which is SINR, and Y is the output, which is the throughput. So once you put a throughput here in this equation, you will get the throughput value, and then you can plot it, and you will see a line here, which is a kind of a linear line or a linear correlation here between the SINR and throughput. And this is where we are going to use machine learning, specifically supervised machine learning. Another example could be similarly if you would like to have just a classification problem. So this one on the left is a regression problem. We will talk about that. It means that continuous change in the SNR will change the throughput continuously. So that is a regression problem. On the other side, there could be a classification problem where we would like to just identify that either customer will churn or not, depending upon certain factors. And that those factors could be maybe how many call drops they had, how their data speed is, or maybe their bill is very high. So those kind of input categories will factor in, and we'll say that if it is green, it means it doesn't churn. If it is red, it will churn. So we are just classifying on the basis of the database. And that is broadly, different use cases of supervised machine learning, and we'll get into more details. What are the different applications of supervised learning in telecom network? One could be, we just talked about it, depending upon the SNR or the quality, how the throughput is going to change in the network. So for any new network or any existing network, if you have samples and database and you would like to deploy a new technology in a new city, and then you would like to understand that how this quality is going to impact the throughput and how much quality you can achieve, and then you can easily offer customers the plans where actually you can provide those kind of data speeds, which is more realistic. So it can be used for different possible scenarios. Similar to this, there could be another use case which is related to identifying certain network problem. And this is more about a class. When we talk about the classification earlier, the first one is a regression problem, where the continuous change in a quality is leading to a continuous change in a throughput. Another could be we have a different classification if there is a poor SINR or poor quality or poor signal level. In that case, there is a network problem. So we will have certain clusters where we'll have a poor quality and poor signal, and we'll identify it as a network problem areas and have some improvement plan on the basis of that. So third one is a traffic prediction, where we'll predict on the basis of the data, whatever we have, the past data, we can predict that how the traffic is going to change tomorrow, and when will the peak for a particular site or a particular region tomorrow, and we can identify it on the basis of the past data. We have a past data for many months here for different sites, different regions, and we can, on the basis of that, machine will predict, okay, this is the correlation I got. On the basis of that correlation, I'll figure out that how the traffic looks like tomorrow.